Today we're still using synthetic division, but this time we're going to find zeros and roots. And as we go, we'll distinguish between zeros and roots again. Our first problem here says divide g of x, which equals x cubed minus 4x squared minus 2x plus 3 by x plus 1. Well, with synthetic division, I want to see if I need a placeholder. Third power, second power, first power, zero power, no. Don't need a zero placeholder. So coefficients 1, minus 4, minus 2, 3. Run through, think a minute. Since this is x plus 1, x would equal negative 1 if I set it equal to 0. So I'll run through a negative 1. Bring down the 1. Negative 1 times 1 is negative 1. Add. Negative 1 times negative 5 is positive 5. Add. Negative 1 times 3 is negative 3. Oh, can you see what they're doing? I feel comfortable finding the zeros of g, at least partially, because I see that I have a factor already. And I have a 0 already. So what do I have? I'm putting in 0 for g of x to find zeros, because remember, by definition, if we're looking for a 0, we're looking for the x that goes with y being 0. So 0 equals x cubed minus 4x squared minus 2x plus 3. And I already have a factor of x plus 1. Because one of the zeros is x equals negative 1. It came from this factor, or could come from it. The other factor that goes with x plus 1 is right here. X to the second minus 5x plus 3. Now try as I might, I just can't get this little fella to factor, can I? So what do I do when I want to get those two zeros, and I know they're 2 because x is to the second power? Yes, you're right. Quadratic formula. Now, if I'm looking for zeros of a function, those zeros could be imaginary. That is a possibility after all. So let's see what we have. Using quadratic formula, x equals minus b plus or minus square root of b squared minus 4ac, all divided by 2a, and I'm zeroing in here, so my a is 1, my b is negative 5, and my c is 3. So let's get ourselves a little more space to work. And the next step shows us going to x equals minus that negative 5 becomes a 5, plus or minus. I square my negative 5 and get a 25, bring down my minus, and then multiply 4 times 1 times 3. And get a 12. Let's trim up our negative here. We brought down the minus, then we multiplied the numbers, and that's all divided by 2 times 1, which is 2. So x equals 5 plus or minus the square root of 25 minus 12, which is 13, divided by 2. So now we can go back to our list and say that we have a 0 of x equals negative 1. We have a 0 of 5 plus the square root of 13 divided by 2. And we have a 0 of 5 minus the square root of 13 divided by 2. And usually we want exact zeros rather than decimal approximations. So this would be our answer right here. We found the zeros of g because we plugged in 0 for g of x. On this next problem, our directions are to solve 7x cubed minus 5x squared minus 16x minus 4 equals 0, given that negative 1 is a 0 of g of x equals 7x cubed minus 5x squared minus 16x minus 4. Well, if negative 1 is a zero of the polynomial, then it is a solution or a root of this equation right here, because plugged in, it gives a zero which satisfies that equation. So this time we're looking for roots since they've given us the zero, and we already know that one of them is negative 1. That means that I can take this side and factor it into x plus 1 times something and get 0. Okay, how do I get the other factor? If I tell you that one factor of 100 is 25 and you want to know the other factor, you would divide, wouldn't you? That's what we're going to do here. We're going to divide using synthetic division. So let's check and see if we need 0 placeholders. Third power, second power, first power, 0 power. We need no 0 placeholders. So copying the coefficients, 7 minus 5 minus 16 minus 4. And I'm going to run through that root of negative 1 that we know is there. Bring down my 7. Negative 1 times 7 is negative 7. Negative 5 plus negative 7 is negative 12. Then negative 1 times negative 12 is positive 12. Negative 16 plus 12 is negative 4. Negative 1 times negative 4 gives me positive 4. And sure enough, I have a remainder of 0. And I expected that since I knew that x equals negative 1 was a root. So my other factor has coefficients right down here. So that's 7x to 1 less power than our 3 up here. So that would be 7x squared minus 12x minus 4. And now what I'm going to have to do is either factor this or use quadratic formula. Well, needless to say, I'm going to try to factor it. So I bring down the factor I already have, and I'm going to zero in on factoring this. So I'm going to use a 7x times an x to force my 7x squared, since this is a trinomial in descending order. So 7x times x, yeah, that's x squared. Then I'm going to get my minus 4. That means I've got to multiply by 1 plus and 1 minus. I could use 4 and 1, 1 and 4, or 2 and 2. I think I'm going to use a 2 here. See what happens. So I have forced the negative 4 because positive 2 times negative 2 gives us the negative 4. Now to see if we're right, we have to check our middle term. So O and I in FOIL added together. This gives me negative 14x plus 2x. That's just what I wanted, negative 12x. So these are the factors, x plus 1, 7x plus 2, and x minus 2. Well, we know what to do next. We're going to set each factor with an x equal to 0, and we'll have all of our roots for our equation. Well, we already know that this one leads to x equals negative 1. But we'll let 7x plus 2 equal 0. Then we'll let x minus 2 equal 0. Subtracting 2 from both sides, we get 7x equals negative 2. Divide by 7. And we have x equals negative 2/7 for a root. So let's list it up here. X equals negative 2/7. And then on the next one, if I add 2 to both sides, I get x equals 2. So that's another root, x equals 2. With an x to the third power up here, I expect 3 roots, and they all happen to be real. So there are our real roots for this equation. we're going to solve one more equation. Oh my goodness, they have given me no clue how to start off. This is bad, y'all. Bad, bad, bad. You know, what am I going to do? What do you think about letting the calculator help us? Because a few minutes ago, we were given a 0 or a root to get started with, weren't we? So if we put y equals this polynomial right here on our calculator, and then look to see where y was 0, I think we'd have it where we could get started. Hopefully, we've got something that we can use here. So let's put it on our calculator here, and we will type in the polynomial, which is 8x cubed, 8x to the third power plus 21x to the second power minus 83x minus 156. And we'll see if this helps us get started. So let's graph it. Now, I don't think it really matters if this graphs off the screen somewhere. We're just looking for 0. So all we care about is this line where x equals 0. I think I'm seeing a 0 when x is -4. I think I'm seeing one when x is maybe a 3. Let's look at our table and see if we really are. Yeah, -4 is a 0. See if 3 is. Yeah, so 3 and -4 are zeros for us. That ought to help us a lot. 3 and -4. Let's go back to our work and let that help us. We know that two answers are x equals 3, x equals -4. That means that x minus 3 is a factor. It means that x plus 4 is also a factor. And then I'm missing a factor. Could multiply those together and use long division. I tend to like synthetic division better. So I think since I can't use synthetic division with anything but linear, that what I'm going to do is figure out what this long factor is here. So I'm going to run through a 3. Let's see if I need any 0 placeholders. 3, 2, first power, 0 power, don't need any. So writing down my coefficients, 8, 21, -83, -156. I'm going to run through a 3, and I know I get a 0 when I run it through. So we'll look for that. We'll know we have a mistake if we don't have a remainder of 0. So bring down the 8. 3 times 8 is 24. Add, and we have 45. 3 times 45 is 135. And then add. 5 minus 3 is 2. 13 minus 8 is 5. 3 times 52 is 156. Sure enough, we got the remainder 0. So now we can tell that our coefficients are correct. So we have an 8x squared plus 45x plus 52 here. I wonder if I can factor this by hand, or do I need to use synthetic division again? Do you remember a few minutes ago we said we knew we had x minus 3 as a factor because x equals 3. We knew we had x plus 4 as a factor because x equal -4 was a root or a solution. I bet with that we can kind of force that other factor and not have to go to synthetic division, though we could if we wanted to. I'm going to have an 8x to get this 8x squared. 4 times 13 gives us 52. Since that's positive 52, I'll need positive times positive. Now the question is the middle term turning out? We better check it because we could have a mistake. So checking, the O outside times inside gives me 13x. Outside times outside, 13x. Then inside times inside gives me 32x. Add it, and guess what? It is exactly what I want. So now I know the root that comes from this one. I know the solution that comes from this one. All I have to do is set this equal to 0, and I will have my last solution. So let's get us a little workspace here. And we'll set 8x plus 13 equal to 0. Subtract 13 from both sides to get our x term by itself since it's linear. And we have 8x equals negative 13. Divide both sides by 8. And we have 8 equals negative 13/8. So now we have our last of the 3 zeros that we knew we had, and they're all real again. X equals negative 13/8. There are our 3 zeros and our solutions to this equation, and they are all real. That winds up our synthetic division section because we've now seen how to solve equations using synthetic division.